now one more talk by Maria. Now on the cinema arts or performing arts, so yet another vertical industry, very vertical to ABB. Okay, the laptop is running.
So yeah, I couldn't make it today, so I'm going to jump in and try to explain you this transforming the arts industry that we want to do here. So Ali was going to explain you more about the, let's say, the creative input, but since I am a technical person, I'm going to talk to you about the technical perspective of this project. So what we want to do is try to bring on the new technologies into the theater, right? So theater is quite a, let's say, trending industry, right? But it hasn't changed much since Shakespeare time, right? So you go there, you sit down, and you watch someone perform. And right now we are talking about these new immersive experiences that we want to bring into the broadcasting industry, or that we have, for example, in the cinema. And also we have seen that business like Netflix has completely changed the business of the cinema, right? And how do we consume nowadays this kind of content? So what we want to do is try to bring in this into the theater, right? So how are we going to do this? So we have seen that this immersion, it requires 5G connectivity. That's what we have learned so far. Why? Because we have very high data rates that we need to transmit if we want to connect different venues together, right? So we are going to have one theater, let's say an exterior set, and another theater, all of them with different audiences, and they have to experience similar but different live experience, and we need to connect them in real time, transmitting high definition video, for example, and sound as well, and we also want to integrate other senses. So we have seen that this requires very vast data rates. We also see, we have seen that latency it's of great importance in this sense, because as we will see in the requirements part, professional musicians can recognize even the slightest outage in the network, and also having all of our flows connected simultaneously makes huge synchronicity problems. So all of this needs to be taken into account when creating the network that is able to deliver this kind of experience. And so how are we going to do this? So we want to integrate technologies like mobile edge computing, network slicing, new radio access technologies, and also we want to include as much as possible the Internet of Things. So we know that immersion is all about bringing new senses in here, right? So we want to have the vision, the audio that we already have, but we also want to integrate touch with a tactile experience, or we want to integrate it also with a kinesthetic experience, that it's the fact that you can feel force, right? And also it would be great to include also emotions into this. So how can we create new emotions with these kind of performances? So these are some requirements that we have gathered from other experiences, and now our stage in the project is trying to see if these requirements are actually like this, or if they were kind of over-provisioned. So we need very high capacity in the order of 1 gigabit per second, or even more if we are going to aggregate more than one flow. It depends on the number of cameras that we have, it depends on the number of microphones that we have, so we have a lot of commitments here. There are past experiments that would tell you that a two-way networked performance, which basically is having two different venues connected and transmitting live experience from one to each other, would require a 1 gigabit per second capacity leap. You might think that's a lot for video, but it's quite accurate, as I will show you later. When we want to integrate a third venue, then the capacity increases not only because we are going to send more data into the network, but also because we need to have a stable latency among the different venues, right? And that sometimes when we want to reduce latency, what we do is we increase bandwidth. So what we have seen already is that 50 milliseconds of stable latency between the three different venues is kind of a reasonable requirement. And if we go more than 100 milliseconds of difference, then the experience would be quite bad. Not only for the audience, but also for the performer to be able to cope with that difference of latency. So if we want to integrate three different venues, and I have one venue that has 100 millisecond latency and another venue that has 150 or 200, that is going to be even more challenging. So if we want to work with a certain level of latency, we need to ensure that that certain level of latency is the same among the different venues, from my personal experience where I am, right? And what about reliability? So as the theater says, the show must go on, right? But we still need to ensure that things are going to go the way it needs to go. And professional musicians can recognize a 5 millisecond outage while playing remotely with other performers, right? So we need to ensure that our network doesn't shut down even for 5 milliseconds. And the audience would recognize a 20 millisecond outage in terms of sound. So all this comes from past experiments that have been done by producers, creative directors, and people in the engineering community have gathered these numbers. And our vision here is to bring in different type of technologies, not only projectors or screens, but try to integrate augmented reality or virtual reality and what we call here the Dolby surround system, which was created by a professor here in KCL, which is an enhanced 3D sound system. So as you can see here, we can have different instruments that can generate these 3D surround system, sound system, and then we have a live actor that is interacting with a virtual actor that can be either on a 3D studio, for example, or in another place, as I was explaining, right? So if we want to connect two different theaters, this virtual actor would be somewhere else. How do we want to put this virtual actor in our stage? So that could be done with augmented reality glasses, or at some point we would have to use projectors, right? We can also bring the streets into the theater, right? If we want to use exterior settings, we can put cameras there and bring that content into our live experience, right? So we are no longer bounded by the room, so now we're bounded by technology. So what kind of capture systems we are considering here? As I said, so we will have the visual effect is going to be either in the live stage, either in the augmented reality glasses, or we can even try to interact with our handset as a user, right? As well, we want to use this immersive audio system, and we know that we will need some loudspeakers around that would be able to transmit the different audio signals that are being generated among the different venues. And we also would like to integrate haptics, and we're still looking into how we're going to scale haptics into, let's say, a room like this. So if we can have, for example, tactile gloves that people can touch what they are experiencing in the set, or for example, if you want to at some point have the same vision as the actor is having, and then you can touch what the actor is touching. There are several ways of doing this, and here the problem is the availability of hardware to do such thing. But we are looking into how to integrate haptics into this context. So what we're doing here at KCL, also working with a number of partners, and this is a project that is growing every day, and now we have a huge number of partners. We are working in a co-design process. So the problem with artists is that sometimes they want to use technology, but they actually don't know how to use it. And people from the technological point of view, we create technology sometimes just because we want to evolve and we want to bring more data rate, low latency, but then the artists would get this technology and they would actually don't know what to do with it. So what we need is to co-create this, right? So we need to sit down together, artists, directors, producers, even if the audience was available, it would be okay as well, and try to co-create this. So we need to bring creativity within the boundaries of technology, but we don't need to limit technology because of this, right? So our procedure now here is that we are trying to measure things and we are trying to bring on the different thresholds, for example. And for each threshold of, let's say, video transmission, audio transmission, we are going to have some creative solutions to work with that, right? So, for example, if an actor needs to delay with some a conversation, or if we have to create a different type of set, because we need to work with that kind of technological boundaries. So, this is the more techie part. We have created an overall architecture of how do we want to connect this. So we want this to be a 5G showcase, right? So we want to show what 5G is capable of. And we believe that this would set the ground for a high number of use cases, right? Because if we can bring in the high capacity, the low latency, the synchronicity of the different flows, so this is a good learning process for all of us. So we have 3 different stages: Theater 1, exterior sets, Theater 2, and they are going to gather and broadcast the content with the use of wireless. So we are using here indoor cells, but we are open to any type of other technology because we still don't know what we're going to use. Then the idea is to aggregate all of that and send it to a switch that it's going to have an SDN controller that is going to do the QoS part. So far we have progressed a lot within the SDN QoS handling here by trying to isolate the different flows and trying to accomplish the data rate that we need. And then the control plane is going to go through the 4G network, and then we're going to have the data plane here handled at KCL within, in our lab here, in the 5G lab. So this is a high-level architecture, but then this is work in progress, right? So every day we're learning and we have to modify this. So for example, I want to briefly mention about the technical facts that we are seeing now, right? So we have this kind of test bed here in the lab, but we couldn't use the 4G base station because of lack of spectrum. So what we are using is a wired network with the SDN switch in the middle that will handle the quality of service, right? So we generate video with a webcam. We use a software in the PC that it's called UltraGrid, that it has been specifically developed for these kind of applications. And then we transmit it and we receive it in the other computer. Simple, right? Well, we have seen that we are far from obtaining the numbers that are necessary for the network performance. We know that one webcam video feed with very limited compression, the smallest that we can use, is generated 180 megabits per second, and the latency is towards 200 milliseconds end to end. I said 200 milliseconds is not possible for network performance, so there is a lot of work to do here. So how can we address this challenge? So we would have to look into compression, but compression would bring latency. So this is, we will have this commitment here of data rate, compression capabilities, and the delay that we need to establish. So this is where the co-creation starts. So we know that we are going to have some technical boundaries, and we're going to tell the creative people, look, this is our table, let's say. So with this compression, you will have this latency and you will have this capacity. With this technology, we can handle this much capacity. So let's work with this. So for example, this is another experiment we did here. The computer here, it's generating video with these 2 webcams. One video is in 1080p and the other one is in 720. The total traffic generated in the network is 160 megabit per second with the 2 videos, and it's hardware compressed inside the camera. because the camera is connected with USB, so we can't generate raw video and transmit it because USB cannot simply handle that data rate. And this is the best we have found so far, which is 170 milliseconds transmitted both videos here. And the good news is that we had perfect latency stability. As you see on top, we have one of the video feeds, which is 58.960, and the other video, which is different flow, it's the same, 58.960. So we were really happy when we found out that we were able to transmit video through the network with an SDN switch, and we're not having any kind of asynchronicity between both video feeds. But still, latency is a problem, and capacity as well, because as you may know, we don't really have a 5G network to work with, so we need to work with the technology that we have. And 160 megabits per second for 2 video feeds, it's a lot. So how are we going to address this? Some of the things that we are looking into in the center is, for example, how are we going to deal with the uplink? We are downloading as much as we are uploading. This is a very symmetric use case, right? So we have as much as downlink as we have downlink. So one of the things that we have been looking here is the uplink and downlink decoupling. So essentially this idea is that instead of me transmitting to a base station that is quite far away, I'm going to transmit to the base station that is closer to myself, even if my downlink is better to that base station. This has promising results in terms of improving the uplink capacity, but we still don't know if this is going to make a huge difference in our use case. So far we have simulated this, and it has really good results in terms of reliability for the uplink and in terms of capacity improvement. But still there is a lot to do here. And what about spectrum? What are we going to do with spectrum? Because we know that if we have like 20 megahertz bandwidth, the best we're going to do is like 100 megabits per second with downlink. So technologies like carrier aggregation here are very useful, but still with the uplink we have a problem. And then we will need to integrate multiple radio access technologies. So we could look into millimeter wave to have huge bandwidths available and try to improve this capacity here. And how are we going to handle quality of service? So in our center here, we are experimenting a lot with haptics. So in the lab, we have an SDN network that will handle an end-to-end haptics communication, right? So we have a robot, master robot, and a slave robot. And we can teleoperate between both. And why is this important? Because haptics has a very stringent delay requirement, and so SDN quality of service, it's giving us a lot of knowledge in how to manage this. As well, if we want to integrate video on top of this, SDN is going to help us to handle the requirements simultaneously for the different flows. So I would like to show you an experiment that we have. I don't know. Oh, what happens here? Okay. Sorry. I don't want to press play. No? Rosas has to do it. Okay. So here we have the teleoperation, and you can see how when we can't assure the quality of service, then this device here is not even noticing that the device has an object, and it's continuing its own movement, right? Whereas if we have a good quality of service, then we can ensure that this device can notice when this other device touches an object, and you can feel it. So with this, what we are doing is trying to perform the queues within the SDN so that we can ensure that our traffic it's handled with the priority that it needs. So far what we want to do is to integrate more flows into this equation, right? So we're going to have video that it has its own requirements, audio, and haptics. So all of this together is going to give us the experience that we want in the network performance. Thank you very much.
I understood the scenario well, then you illustrated a scenario where artists are interacting in an inter-venue scenario, right? And then you have defined latency requirements for this, as I understand. But what is with the human reaction time here? How you deal with the human reaction time here?
Yes, so here we have two types of let's say, challenges. We have the challenge of the audience, that it would be with the human reaction time, but then we have the challenge of interacting. And the challenge of interacting, it depends on the way you are interacting. So for example, if we are going to use augmented reality, then the requirements are going to be much shorter because it's not any kind of visual experience, right? So you have a problem within the technology that you're going to deliver, right? So augmented reality, we know that has a very small latency. But if we are going to work with projectors, then your latency can be possibly much higher. But within the actors, this is the strong requirement. They can learn how to do it, but for example, with music, the latency is going to be much shorter. It all depends on the type of network performance that you want to do, the level of latency that you can allow yourself to.
Okay. Thank you.
Further questions?
Thank you. Just a quick question. I just wondered how you got to the 1 gig per second, and then also how is it compared to the cinemas now that they already have the data throughput to stream the 4K films centrally, and what is their throughput? Thank you.
So if I remember well, I think that 4K, if you don't have any latency problem and you can compress it, good, then you can reduce the data rate up to 100 megabit per second or even less. That depends on the allowance of latency that you can have. So as for your question with regard to the cinema, this is a live experience, so we are operating in real time. Cinema would have a similar experience as a broadcast. Right now, DVB-T or LTE broadcast can give you numbers such as 4 seconds of latency, which it's hardware compression problem. So we have now we know that 80% of our latency is in hardware, and we need to deal with that. So if you don't have a real-time interconnection between different venues, then you could work with that because you're going to receive your data 4 seconds later, and you're not going to experience any lag problems. But when you have two live venues interacting, then it's the problem of the latency. And so for a question on the capacity, so capacity and latency are those concepts that go together. So if we don't allow ourselves to compress that much because we need to buy time, then we need to increase in capacity. So even a very small experiment as the one that we have done with very off-the-shelf products as a webcam, it gives us 180 megabit per second, just one video flow. And one of the things that we have been seeing is that the network performance industry is over-provisioning just to avoid kind of bursts. And for example, the video would send information in bursts, right? Because it depends on the frames that it changes. So all of this, it's a commitment that has been done, and they arrive to these numbers of 1 gigabit per second or 10 gigabit per second. But so far, if we want to aggregate different camera feeds and we need to transmit that data in RAW, numbers are not that big. I think that if you have like 5 or 6 different cameras, and then you have also the audio that is being transmitted uncompressed, you easily arrive to the 1 gigabit per second data rate.